Alright, let's get started now. So today our type alongs will be, they might be a little bit complicated, but um, you guys should be able to do them. And before we start, I also wanted to make an announcement. So I'm actually like building this nonprofit. It's gonna be called the Scholar AI, and we're gonna be like building educational tools with AI. And if you guys are like liking these classes, which are like a part of the nonprofit at the moment, like feel free to donate using Zelle and my email, which is the Zelle ID, krishay.db@gmail.com. I would greatly appreciate it if you could. Um, so yeah, there's that before we get started. But now, yeah, that's the announcement I wanted to make. Let's get started with error handling and file I/O. So when we were so when we were making our programs, right? When we were getting the input and when we wanted to actually have the user enter in something, we were doing something similar to this, right? So we would import our scanner. To use the scanner class, we would make a class header and our main method, and then inside the main, we would actually initialize the scanner like that. We would print out our prompt, and then third step would just be to create a variable for the input and then get the user input like that using the method from the scanner class. But this is prone to errors because you never know what the user is actually going to input, right? Like they could enter a string, for example, when you're asking for an integer. So you have to check somehow to make sure that um, this program won't throw any errors. And if it does, like how can we handle those errors? How should we actually like take on that challenge? So in Java, actually first let's see how um, actually I'll leave that for later. So yeah, let's just continue on. So why do we need to handle errors? Because oftentimes errors stop our program execution and will interrupt the user experience. They show the user that our program doesn't work as expected, which is pretty bad for people who actually want to use our product if we're like making a product with Java. And in general, it improves um, our ability to handle errors improves reliability and robustness of our program. And you should always like assume that users can break something, so that's why you need to make your programs as reliable as possible, which is how we'll learn to handle errors. So let's see what happens when we run that first program, right? So here's my terminal in VS Code. So this CD6 just means I move into the 6 folder. I have a folder called 6 within workshops. So I move into this folder and then I compile with Java C and then I run with Java. And then I print the prompt, right? So please enter an integer, but we enter a string. And then we get this exception. So exception in thread main java.util.input mismatch exception. And then it gives us like a bunch of locations of like where the error was called. So it already tells us like it was in this thread main, so we know it's in the main method, right? Um, this part right here, this tells us like um, the actual like location of where the what's it called, the error is defined. So errors are like also classes in Java because everything in Java is object oriented programming, right? So errors can, they're also like defined similarly to classes. And in this case, we can see that the package that it's in is java.util. So this is something that we can also import into our program and use, like scanner, how we were doing that before, like java.util.scanner, but in this case it's an exception called input mismatch, because our input does not match what we were expecting, which was an integer. So that just goes to show like how everything in Java is object oriented, and how like the power of object oriented programming actually works. So if you click on like one of these, this will like actually take you to the place where the error was called. We'll see this in like the type along. Um, but yeah, I just wanted to show you this because that's like pretty important to know how errors are defined as similarly to classes. So we'll be also importing them and then using them like classes in our program. Um, I think the next part I put on here was like how we can actually handle these errors and how we can fix them. So in this case, we have this structure called a try-catch structure. This means that we um, will try to do something, right? We attempt to do whatever code we put in this try block. And by block, I just mean like these curly braces. And then, you know how in Java we actually refer to errors as being thrown? So when we get an error, we actually say like the program throws an error. Well, to handle that, we would say we would need to catch it. So it's kind of like you're throwing and catching, but instead of like with a ball or something like that, we're doing with exceptions. So you'll say catch after your try block to handle whatever error that might be thrown by this code. And then you put your exception that might be called or like that might be thrown by your program, and then you put like a variable right here. So this variable is going to be an instance of this exception class. So this just goes to show how everything in Java is object oriented, even for exceptions, because we're making an instance right here. And then we'll use this instance to actually access our specific error that was like thrown by the program. So in this case, we're just like printing it out, but in general, there would be like a method called print stack trace, and this would show us like the main details of the program, like where the error was called or where it was thrown, um, how we can handle it, and actually like the name of the error as well. So that method, which we will see later on, will give us a lot more useful information than just like printing the error like this. So yeah, that's the try-catch structure. Um, I put an example there, but yeah. So the main idea is that we can try to attempt running some code, right? And then we can um, catch and handle an error if we do get it. If we don't get it, if we don't get like an error, then this block is not going to run at all, right? It's just going to continue on after this. It's kind of like an if-else, but um, try-catch rather. So yeah, there's that. Um, as for the code implementation, here's like an example. So right off the bat, you can see that we are importing an error right here. So using this, um, using this path right here, we can find out like the input path for errors, exceptions, and then we can use that in our program. So if you see like I got an input mismatch exception, you can make a try block, copy this right here, and then paste it into your import statement, and then you will be able to handle that error. So you'll say import java.util.input mismatch exception like this, and then this is our previous code for like the scanner. Except this, at this point, I'll put the try catch. What goes in my try is whatever code that I think will cause the error. So if you're making a scanner, right, this is not going to cause an error. For sure, you know that that's not going to cause an error. Same thing with this print statement. However, the thing that may cause an error is this input statement right here. Like when we are accessing whatever the user is going to enter. So that's the part that can cause the error, which is why we put it in the try catch, because we want to try this code and see if it works. And then this, honestly, this print statement, it can go after the try block, but I mean, I guess I just put it in here for ease of access or something. I don't know. Anyways, but the main idea is put your code that you think will cause the error inside the try block. And then in the catch block, you put your exception like this, and then you'll put the instance, the variable name, and then you'll print it out in this case. So if we run through this, let's see what would be different compared to what happened here. So let's say we entered H, and then this exception was thrown, right? So instead of printing it out to the terminal, what it would do is, actually in this case it would print it out to the terminal because that's all we're telling it to do. So yeah, I think the output would be similar there and here. But if we didn't have this piece of code, then nothing would be printed out to the terminal. So this code, it controls what would happen if we get the error. right there. Alright, so there's the basic try-catch structure. Now we can look at this other one. So another possible structure for try-catch is having multiple errors. So this code right here, not only could it trigger like an input mismatch exception, but let's say it triggered like an arithmetic exception. Like we were dividing by 0, for example. In math, you know you can't divide by 0, right? Because it's undefined. That's just like the general standard. But if you get like that kind of case in your code, then it's going to throw like an arithmetic exception. So let's say we had 2 of those exceptions that could be thrown in this code. So each of those, you would make a try or catch block for that, and then you would handle it with each of those. Each of those would handle one of those errors. So you could say input mismatch exception here, and then arithmetic exception right there. And in both cases we would just print it, but you could do some other stuff with it as well. So one example of something that you would actually put in here, maybe for like your application, was that you would print out a message to the user saying that an error occurred, and then you could attempt to like restart the program probably if it's like a fatal error. Fatal means that it's like terrible, that it could like potentially crash your application. So yeah, in your catch blocks you would probably do something else other than just printing the error, because that's already what's done by default.
Excuse me?
Yeah.
So, like, what happens if there's an error that you haven't listed in the code? Will it just show that kind of error, or will it just not do anything?
That's a good question. So the question was, what happens if there's an error that's um, not mentioned here, or like that you don't include? So if you don't include an exception in here, then it's going to run as if it would as if there were no catch block for that. So it would do something like this. Because you
Oh,
haven't
okay.
done you haven't done anything to handle that. So it's not gonna look at any of those cases. So yeah, it just looks at whatever you define. Um, so yeah, there's that for the like multiple catch. Um, you'll most likely be using this more often. Like I haven't really used this that much, but there's always like potential for multiple catch blocks in case you have like some code right here. One more thing is that you can see that I'm making like exception right here. So in Java, exception is actually like a class. It's a valid class, and this can be used to like handle any exception. So in the case of like Arusha's question, like we saw that it wouldn't this program wouldn't handle an arithmetic exception if it occurred, because we only check for this input mismatch exception. But if this class right here was just exception, then it actually would handle that arithmetic exception along with input mismatch exception. And the reason for this is something that we'll see in the next class, or the one after, whenever we discuss inheritance. Um, but for now, just know that if we say something like this, exception, then it means in a general sense that any exception can be handled. So yeah, that's an important distinction to make. Alright, let's move on. So I think we can go actually do the type along right now, because that would make more sense. So let's practice the type along actually. So I'll give you guys some time to do this, like work on this for some time. So in this program, what we will be doing is we will be practicing like the stuff that we just learned about error handling by first like handling multiple exceptions. So we're going to be taking in input from the user. So let's read what it says. So first, create your basic class structure with your header and main method. Inside, initialize a scanner object. Then, using a try-catch structure, first ask the user to enter a number to divide 100. So that means that like you'll ask it for some input like x. I use the variable x here, and then put x as a denominator, the number that goes on the bottom of the fraction. and then divide that number and then print the result. So you can just say like system.out.print and then whatever this value is. And then create an array with 3 numbers and ask the user to enter an array index. Then print the element at that index. And then for both of these cases, catch the respective exception. Let me check if there was something else. I think there was. Right, so when you're handling this first case, you should catch an arithmetic exception. I'll put that in the chat. Arithmetic exception. So arithmetic exception like that. And then for the array, the exception that you get is called array index out of bounds exception, like this. And the only one that you need to import is the input mismatch exception. So when you're getting the input, you'll be checking for this input mismatch. So yeah, you'll be handling these 3 errors in this program. So I'll give you guys around like 10 minutes because this program might take a while. So I'll come back after 10 minutes. Starting now. Alright. So if you guys are having like difficulties with this, what I'll do now is I'll actually like put this thing called pseudocode. So in CS in general, you can use pseudocode, which is like it's like code, but it's more general, and it helps you like plan programs. You can use it to plan out your code and decide like what variables do I need, what classes do I need, how am I going to use like these methods and stuff like that. So I'll put some pseudocode in comments. I'll start typing that out. So yeah, let me share my text editor. Alright, so we probably have like the 6th folder for this class, and we can call it, I called it like input tester, right? Let me check. Yeah, input tester dot java. So for this program, we'll need our basic imports, right? So we need, the only one that we need to import is input mismatch exception for our scanner methods, right? And then we need our scanner as well. So those are our imports. Then we need to make our class, right? So we'll have input tester, and inside the main method, what we can do is we can say initialize scanner, because that's the first thing we need to do, and then we'll have like a try block. So try something. What do we need to try? Well, we need to first, wait, actually let me put the prompt in here. That makes it easier. So first we need to create a basic class structure with header and main, and then initialize scanner. We've done that. Then we need to ask the user to enter a number to divide 100. So try, and then we can put our prompt here, and then we can do print like 100 divided by x, and then yeah, then we do this part, divide that number and print the result. That's what we're doing right here. but we need to catch the exception that might happen here. So catch, well, one exception that we could probably get is the arithmetic exceptions, right? So arithmetic exception. In the case that we get an error like this, what we can do is we can just print an error message to the user, like error division by 0, because that's what causes the arithmetic exception. Then inside the same try, what we can do is we can also do this next part. So it says create an array with 3 numbers and asks the user to enter an array index. Then print the element at that index. So we can actually do this outside the try, but I'll do it inside. So we can say int array, that's the integer array, and then we can call it nums equals 1, 2, 3, right? And then we can just say our prompt, because we need to tell the user to print or enter something in, and then ask them to enter an index. So I'll just put that, ask user to enter index, and this index will be used to access one of these elements in this array. So 1, 2, or 3, right? 0, 1, or 2. Those are the indices. So then we need to get that result. So we can store it in some variable called index, store user input, like that. And I should have done the same thing here. So for this case, I could say x store user input, and then I would need to like print the element at that index. So in this case, I would need to do print nums, and then the index would be index, like that, because that's the variable that contains the index from the user. However, we need to catch the exception that could be run by this. So in both of these cases, there was something that we forgot to do. We didn't catch the input mismatch exception, so I'll put that input mismatch exception. In that case, I would just say invalid input type. Now in this second case, we need to actually catch the array index out of bounds exception, and we would just say array index is out of bounds, which means that we entered something that was not a valid array index, like 600 or -9, something like that, because we only have 3 elements, which means we only have 1, 0, 1, and 2 as possible indices. So yeah, there's the basic program structure. I'll give you guys like 3 more minutes to see if you can write the program based on that. Alright, so that's time. So let me know how this program was on a scale of 1 to 10, like 1 being the easiest, in the chat. And then we'll get like started with like the actual code. Alright, anyways. So, well, actually, do let me know, like, how it was, so that I can, like, um, calibrate, like, the other programs in the future. But, for now, yeah, if you haven't finished, then it's fine. Let me just do this, and then, yeah, scale of 1 to 10. Alright, so, for our input, we planned it out and said that we would need this input mismatch exception and the scanner. So let's do that real quick. So import java.util.input mismatch exception and then scanner. So like that. So we have our imports right here. Not input, imports. Now we need to actually create the main class. So we already have our code, or we have like the structure for it. So let's just copy this and see how similar it will be. So you can notice how I didn't actually like put all the code that we need, like public, private, system.out. Like you don't need to put all of that when you're doing pseudocode, because pseudocode is just for like planning out your program, and it should be like a quick way to like jot down your thoughts, not like a detailed explanation of what you're going to do. So we have our public class input tester, like that. And then we need to make our main method. So public static void main. And then we'll initialize our scanner. So scanner, I'll just call it KB, which is like short for keyboard, because we're taking in input from there. So that's going to be a new scanner, system.in. And then we need to make our try catch statements, right? So we have our try and then catch. And you can see here that VS Code, what it does, it actually gives you like a template. So if you click on this, it will give you like the full try catch block. And you can see by default it puts in this exception here, but most of the time you should use your specific exception that you will get, because it shows that like you know how your program will work. And in school, if you're doing like this exception handling, that's probably what they will ask you to do anyways. They'll ask you to put the exception that you'll actually get from that, running that code. So in this case we had 3, right? We had arithmetic, input mismatch, and then array index out of bounds. So I'll just copy paste this because I already wrote it out. So catch, and then input mismatch. And the reason why you don't need to import these is because it's imported like by default. So in Java, everything in the java.lang, this package is already imported by default. So this input mismatch and array index, those are already imported by default because they're located in lang. So you can just use those without having to import. So you have those 3 exceptions, right? And then you have the 3 instances of each. Actually, maybe you do need to import array index. No, you don't. Out of bounds exception. I forgot the exception at the end. So yeah, make sure you put exception at the end. Let me just replace that here. So these are the 3 exceptions that we'll be handling. So in our try, what do we need to do? We need to first give the prompt to the user for this first part, which is division. So we can say print, enter a number to divide 100, like that. And then we can say int divisor equals scanner dot nextInt. Now, I mean not scanner, it should be KB. This is the part that may cause an error, remember? So this will be handled with the input mismatch exception. So we're already taking in account for that. Now we need to do print 100 divided by divisor, like that. Or not print, but it should be system.out.print ln. So here we're printing the result of dividing this number into 100. That's the first part, and we've represented that in our pseudocode. Now the next part, we make an array, right? So we say we have an int array called nums, and that's just 1, 2, and 3. Then we need to ask the user to enter an index, enter an array index. And then what we need to do is we need to get that index from the user, right? We need to say int index equals kv dot nextInt, and then we need to just print out the element at that index in this array. So we can say nums index, like that, with index in like the square brackets. So let's identify what all can cause errors here. So we know this part can cause the error. So can this part. Similarly, for this one, it's this part and this part. And all of those will be handled with these 3 blocks right here. So in each of these blocks, we can just say system.out.println like that, and then we can do e, or not e, let's not print the error. Let's just say an arithmetic exception occurred. That's good enough for now. Or let's be more specific. Let's say error division by 0. And then for input mismatch, invalid input. And then for the last one, we can just say error invalid index, like that. So there you have it. Those are our 3 catch statements in our try block. And then we also have our pseudocode. So I'll put this in the code repository so that you can access it. For now, let's move on to the next part, because we don't actually have that much time. But yeah, so there's that. You can copy it down later, because yeah, we need to cover some more material. Alright, so this is our next part. Let me scroll up. It's going to be file input. So when we're reading in for files, it's going to be useful for a lot of different things, right? Like data analysis, analyzing computer logs, and configuration and initialization for systems. So these 3 things are pretty big they're pretty big topics in computer science, which is why I put them. Maybe not like analyzing these last 2, but they're still like relevant for us. So anyways, let's see what we need for file input. We need these 3 classes. So we need this new package called java.io, which is input output. And then we put this file class here, because we'll need to make a file object inside our code. This is it's going to represent the file that we're reading in from. And for this next import, we're going to need a file not found exception. This tells us that we're going to be using try catch inside our program. And then lastly, we're going to need scanner to read the file. So let's see the basic structure. This is kind of like our pseudocode. I put numbered steps here so it's like easy to follow. So we first use a try catch, right? Then we'll make a scanner instance to read in the file, but instead of system.in like we were doing back here, we would actually use the file object that we made to read the file. So the scanner knows that we're reading in from the file. And then we use this loop structure. So while scanner.has next line, this means that while there are more lines in the file, we should store that line as a variable, and then we'll print out the line in the terminal. So we're printing out whatever is in the file into the terminal, in this case. And then lastly, if we get this file not found exception, then we will do this print stack trace method, which I showed earlier. So yeah, there's that. Here's the actual like implementation in code. So this is what I meant by like making a file object. In our try block statement, because this code can throw errors, we first make the file object. This is where the error could occur, so we put the file not found exception. So in this case, I have a file called example.txt. .txt is a text file that just stores like simple plain text. So I put some stuff in there beforehand, and I want to read it using the scanner. So we make a scanner with a parameter of this file, and then we read through that file and print whatever there is in the terminal. Lastly, we close it. This is not required for reading, but I just put it here because when you're reading in and writing to files, it's a good idea to close the scanner in case any other weird errors occur. And then later we catch the exception if it occurs. So we just print file not found, and then we do e.print stack trace. This is going to give us more like detailed information. So yeah, why is it so useful, or why is file output so useful? This is our second topic. It's like similar to file input because we can now manipulate data. We can create computer logs, and then we can configure and initialize systems, so like before. So in this case, in file output, now we have something called a print writer. This is going to write text to the file, and we're going to have this IO exception that occurs if our file is not found, or if like another kind of weird error occurs. So I think this has something to do with print writer and the way print writer works, which is why we need to include it. So in our pseudocode for file output, we need to first create a try catch. Then we create a print writer instance similar to our scanner instance and object. But in this case, we'll be writing to a file, so we use print writer. Scanner is only for reading input. It's like scanning the text that is there. But print writer is going to actually write the text. Then we print the lines in the file. So the way that we do this is by using like print statements actually. For print writer, when you make an object, you can do something similar to system.out. You can say like pw.print, like if pw was the name of our print writer instance. So we'll see how that works, and then we catch an IO exception at the end, and using print stack trace if the error occurs. So this is the example. So first we need to import the two basic stuff, and then we need to create this print writer instance. In this case, it's called writer. It's like our scanner instance called KB or keyboard. This case, it's going to be called writer. And then we make a new print writer using a parameter of this string called output.txt. Right, so then we have initialized a print writer object that will write to a file when we give it like these commands. So to write to the file, we can say .println with the print writer object. So .println, and then we print whatever we want to write to the file, right? So then we need to close at the end. this closing is actually necessary for PrintWriter because if you don't put this, it's not going to save your file. So that's really important for writing, and I just do it with reading as well, like scanner.close, just to keep it consistent. So that's why we have writer.close right there. And then as usual we would catch the exception if it occurs. So I think we have our type along now for file input and output. Given that the last one was like kind of difficult, I'll work through this one, and then we'll see like how we can run the programs, because we actually didn't run them, so we should do that. So let me share my editor again. Alright, so this is what we had before, right? We had input tester. Now this one we can just call it something like write tester. How about that? Actually, let me see the prompt. So we're reading and writing in this case. So let's read the prompt. So it says use a for loop to print numbers inside a file starting from 0 to 100, skipping by 5s. Then read those numbers and print them to the terminal. So let me rename this class actually. Let me call it read write tester. Like that. Read write tester. So in this case, we'll have our main method. One thing you can do in VS Code that's kind of nice is you can just type main and then click enter, and it's going to autofill the main method like that. So in this case, what we need to do first is we need to initialize a print writer to actually write to a file. So we need to import our print writer actually. Import java.io.printwriter like that. And then we can say try catch like this and create our print writer. Print writer. So you'll see we need a file. So now let's import the file. Import java.io.file. This is going to be the file that we're making. So file well, let me check something real quick. Okay, so you don't need a file object for PrintWriter. You can just say directly the name of the file. Let's just call it output.txt like this. And then let's make this output.txt file here so we have something to like write into like that. So that's going to be our file that we're writing to and reading from, and we use that to initialize the print writer right here. Next thing, we need to create the loop to actually write the file to, because now that we have our print writer, we can directly write to the file. So there's only really two basic steps here. Just create your print writer and then write to the file directly. So in this case, we're going to need a loop, and in that loop we're going to print out every number that we iterate through on a separate line. So now this is like where we need to think a little bit. So we're going to start from 0 and then we're going to go to 100. Each time we skip by 5. So we're going to have an initial variable int I equals 0, and then we need to go all the way up until 100. So if you put less than 100, this means that we check all of the numbers if they're less than 100 and only run this loop if it's less than 100. So once we get to 100, it's not going to run because 100 is not less than 100. So we need to put less than or equal to like that. And then we need to increment. So we saw how doing I++, you don't need the semicolon there. we saw how doing I++, this would increase by 1. But to increase like by another number, by another like specific step, we can say I plus equals 5. So plus equals will add 5 and then set that equal to the value of I. So we should not be printing out with system actually. We should use writer. So writer.println, like that. So there's our writing. Now we need to handle the exception. So in this case, we saw that the IO exception was something that could occur. IO exception. But we need to import this, so we can say import java.io.io exception. So there's that. And now we need to just simply say an IO exception occurred. And then we can say e.print stack trace, which is our method to get like more detail. So it says print sys throwable and it's backtraced to the standard error stream. So that just means that we'll get more detail. That's the first part, right? So we finished this part. Now we need to do this next part. So it says then read those numbers and print them to the terminal. So the way we can do this is by reading in. So we need to say try catch again once more. But we need to make a scanner now. So we can say import java.util.scanner. And then this is like some pretty usual stuff. Scanner kb equals new scanner. And actually we're not going to be using system.in. This is just like a force of habit. But we need to make a file, right? So file input file equals new file, and then it's called output.txt, and then we make the scanner with this input file. So there's that. Now we're able to read in. Now we can say while scanner or while kb dot has next line, string line equals kb dot next line, like that. So we get in the next line and then we just print that to the terminal. So there, we've effectively read through the entire file, but now we need to handle the exception. So we're gonna get a file not found exception if this file name is not correct. So the way we handle that is just by saying file not found, and then we do e.print stack trace. So this is our entire program for this prompt. Let's try running it now because we didn't do that. So I'll actually go to the terminal and do this. So you can see I'm in the type logs folder. I need to go to 6 and then make sure my program is here. So we have input tester, read write tester, and then output. So let's try running read write tester.java. So now we have the class, the .class file, and then let's run read write tester. And since we don't have anything in output, oh, hold on, it didn't write to the file, so that's kind of strange. Oh, it's because we never closed the writer. So this is why it's really important to close your writer, because if you don't close it, then it's not going to save your file. So yeah, that's a crucial step that I forgot. I'll do the same thing here actually. I'll close the scanner. Close. So yeah, sometimes when you forget simple steps like that, you can end up with pretty big errors. So let's try recompiling and running it again. And now you can see that we have our output. So there's that for our read write tester. Let's try running the other program that we made, input tester, and see how that works. This is the one that would get the input from the user and then handle the errors. So let's see how we can give this an error. So if we do Java C input tester, and then we run that, it's going to say enter a number to divide 100. So let's try 10. And it prints the result, which is 10, because 10, or 100 divided by 10 is 10. Then we need to enter this array index. So let's try, remember our array had 0, 1, 2, and 3, or 0, 1, and 2 as possible indices. So we can pick from one of those and see that it works, because at index 1 our value is 2. So that works as planned, right? But we need to actually see if our error handling is working. So let's try dividing by 0 and see what happens. So it goes directly to the catch block and says error division by 0. As soon as it gets the error here, it's going to go and handle that, and then it's not going to run any more of this. So that's an important thing to know. This means that if you truly did want to run this code, you would have to put this in another try block after this. So now let's try the other one. So let's say 10. Enter an array index, and let's say 8, for example. And then we see invalid index. This means that at this point, when we try to access that index 8 for this 3-element array, we only have 3 possible elements. So 8 is obviously not going to work, which means that we get this exception. And then it goes down here and prints this, because that's what we told it to do. So yeah, if that's it for this class, I think. We don't have other material. So let me see if there was anything else that we needed to cover. No, there was nothing else. So yeah, you guys are free to go. Thanks for joining this class. Let me see what we'll cover next time, in case you wanted to know. So I have polymorphism and inheritance planned for next time. So that's gonna be a lot more. We're gonna delve more into object-oriented programming, which is kind of the strong features of Java. So yeah, that's it for next time. That's it for this time. See you all next time. So yeah, bye. If you have any questions, you can stick around. I'll stay here for a few minutes, and you can ask anything.